So good afternoon. Thank you for staying. It's been a long day. And so I'm part of the evangelist team in AWS, and I'm specifically focused on serverless technologies. And I'm quite passionate about what you can do with serverless. I also wrote a book on Lambda that has been translated to Chinese and Korean. And I work with my publisher to have a free ebook. So the last one there is a free ebook that you can download. It gives you the basic understanding of how to set up an agile development environment. So what are the required technology and how to start. And the reason we're here today is because we are, I think, interested into serverless. And what I think it's really important, and it's something that has been repeated across, I think, any session today, is that it really allows you to focus on creating business value, on focusing on the unique features you want to build instead of all the management of the infrastructure, of the nuts and bolts that you need to build. And what I've seen actually is that there is a sort of equilibrium that we have to be careful of. So as developers, we want to build the unique features that we have to build, but we also are psychologically attracted by the comfort zone of working with the traditional framework, the traditional technology that we know. So I see lots of people that spend time editing the same configuration file over and over because they are used to do that. They feel comfort in doing that. So we have to be careful to not be attracted by the complexity that we know, because it's something that looks easy and it looks something that we can do without spending too much time, but it's actually removing time from the other part, from the unique features. So if we manage to stay balanced in the right direction, then we get the right speed. And well, this is, for example, a case study in Italy. This is Marco Viganò, the digital CTO of Condé Nast in Italy. And he's really saying something that for me is really important, because what I experienced a few years ago is that IT was becoming the bottleneck of the companies, but IT should really be the excellence center, the innovation center of companies. Should never say, no, we can't do that. It should be where new ideas are implemented and are tested quickly. And if we go in this direction with serverless, we start to gain speed. We saw today we can really build something quickly, but how can we use speed without control? Now, everybody who grew up a few years ago in TV, there was a TV advertisement that speed is nothing without control. How can we take the right steering from our application if we start to go fast? So I think the first idea, and this is something that it's really important to me, is don't think of the project that you build as a project, as a software project. Think of it as a product that you give to some internal or external users. Thinking as a product removes the idea of milestones or a specific start and end date. It gives you the idea that you're creating something that is continuously being used and is developed over time. And when we start to think in this way, it's when the idea of evolutionary architecture starts to be important. So this is a definition that comes from Rebecca Parsons and Neil Ford from ThoughtWorks. And they say that an evolutionary architecture designs for incremental change in an architecture as a first principle. So I started to translate this into what I think is important. So I think incremental change should be, for any software project, your first requirement. Anything that you do, any choice that you make, should be based on the fact that you can eventually change it. The way you store data, the way you process data is something that is not written on stone, so it could be changed. And you should think about that when you do the implementation. And the idea is really that you have your software product, and you want to reach a target. And this target is probably moving because you have new requirements coming over time. So how can we reach the target for changing our product? There's lots of different things that we can do. We can choose to add a new feature or maybe do some refactoring so that adding new features will be faster the next time. We can choose to work on non-functional requirement. Maybe we want to improve the security or we want to improve the scalability of our solution. How can we choose the right direction? To me, this looks like an optimization problem. When you have a space of solution, you have to find the right solution. And this is the way evolutionary architecture can help. Because when you have an optimization problem and you don't have an algorithm that can give you the right solution out of the box, you need to explore the space of all available solutions and find the best approximation that you can have. So if we have our best solution, so this is the ideal architecture, the ideal implementation for our software product that we want to reach, but we don't know how. the idea is to use evolutionary algorithms. Evolutionary algorithms, such as genetic algorithms, they try to simulate what evolution does to evolve species. And the idea is that you can create a population of candidate solutions. So those are all different possible solutions. And then you use a fitness function to find the best solution that are closer to what you want to achieve. Then you discard the solutions that are not good enough. And then you can generate new solutions from the candidate solution that remain there, and then iterate and find other solutions that are maybe closer and go on with this iteration. This is something that is being used over the years. It was not popular a few years ago. Now it's being popular again in machine learning for finding hyperparameters. And it's this mix of generating possibly random solution and then select them using a fitness function and then going on and on with generation of solution and filtering and selection. Problem is that in our case, it's not easy to explore the space of all possible software architecture. It's simply a huge space. There are some studies of how you can generate a random variation of an architecture, but it's probably not something that we can do right now. So we can still use something from this approach, and the idea that we can measure with a fitness function an architecture. And we can measure both an architecture that exists and also an architecture that still has not been implemented. What we can do is we can look, for example, at the source code and use any software source code metrics to evaluate the source code. We can measure the test coverage, the performance, the non-functional requirement. Are we using encryption? How are we rotating our credentials? And so on. And we can add all of this with some weights and define this as a fitness function. So we are measuring this implementation against my targets. And together with the business, you can define how much all of this as a weight. So probably in the finance sector, security is more important than in other sector, and so on. And so we can use this fitness function to measure our current architecture, and the absolute value that we get has no meaning, but we can compare this with other values. So for example, what will change in my fitness function if I implement this requirement, if I implement this non-functional requirement, if I improve security, and so on. And in this way, if we have a current architecture and we have our moving target ahead, we can choose what is the right path. Should I go in this direction? Should I implement a non-functional requirement? Should I focus on refactoring? Or should I focus only on new features? If you define the fitness function together with the business, you have a way to take these decisions without having each time to maybe focus only on new features and forget and accumulate the technical debt. The idea is that over time, if you continuously release new versions of your application, you have a graph like this. No? You have a first release, then you improve the scalability of the solution. This gives you some more points in your fitness function. Then you enable encryption at rest. Then you increase the availability of some component of your architecture. Then you implement encryption in transit, and so on. And you can see this growing trend that is telling you that you're going in the right direction with your software architecture. And when I was thinking about this, I was thinking also, there's something similar here in another field that I'm working on, and that's machine learning. So when you want to train a machine learning model, usually you have a similar concept. It's called the objective function. That is some function that you want to minimize to optimize a model based on the data that you have to do what is normally called the training of a model. And the objective function in that case is something that you want to minimize, not maximize, and has two main components. One component is called the loss. So how good is your machine learning model to predict with the data that you have? And the other component that usually is used to avoid overfitting of your model, so to make your model work also on new data, not only on the data that you're using for training, is the regularization. And this is taking care of the complexity, because if you create a super complex model, there's the possibility that this model will adapt to the data that you have, but will not work with the new data. So you don't want to increase the complexity. And this idea of avoiding to increase the complexity, I think, is very good also for software architecture. So our fitness function can, on one side, look at how what are we doing Are we increasing the security? Are we working on functional and non-functional requirement? Are we improving the metrics of our source code? And on the other side, you have a penalization if you add something. So if I add a new software module, this will be a penalization unless it's growing the fitness a lot because it's giving maybe security or scalability benefits. And how does this relate to serverless? Well, with serverless architecture, normally you have your code, and then you have a template that describes how this code must be implemented, what software components, what services you need to implement on the cloud. And then you package this, you upload it to the cloud, and then you can deploy in what on AWS we call it a stack, that is an actual implementation of your application. And then you can iterate, you can get a feedback from your users, change your code, adapt it, and then deploy it again. And this loop is very important because this is really giving the speed of your team. How much faster you are able to iterate on this feedback loop, that's the speed of your development. Because if you don't get a feedback, you don't know what to do next. And to go fast here, it's really important to be able to deploy the stack in production as fast as possible, but also, since this is production, as safe as possible. So what can we do here? So last year, we focused on this, and we introduced some native features into the AWS platform to allow to do, for serverless applications, all-at-once deployment, similar to blue-green, because you can roll back. Or you can do canary deployments, so you can test on a subset of your users a new version of the function, for example, and if it works, then you can extend it to all the other users, or you can have a linear deployment where you slowly grow and deploy the new version, monitoring that everything is working until you reach 100% of deployment. And you can monitor this with alarms. Those are CloudWatch alarms, so you can monitor. You can use standard alarms, like the latency of your API is not growing beyond a certain threshold during the deployment. Or you can use business metrics with custom metrics that you upload. For example, Netflix, they look at the number of play per seconds. If they do a deployment and they see that the number of play per seconds of their users is changing too much compared to what they released, they expect that something was broken, and they roll back and then analyze the logs. So if you have 1-2 key business metrics that tell you if your business is working correctly, that's the best metric to monitor during a deployment, because if that's impacted, then probably something was not behaving as expected. And we also have hooks. Hooks are actually Lambda functions, a pre-traffic and a post-traffic Lambda function that if you want, you can trigger before and after the deployment. So if we look at time, we create the new version of your function, then you can execute the pre-traffic function that is your code, can do whatever check you want. Before this new version is rolled out to any users, then we have the rollout from 0 to 100%, and then you can run a post-traffic function that can, for example, do other checks when users are actually using the new version of your application. And if we focus here, my idea is that evolutionary architecture can match very well with these two functions, because we can use this function to inspect what we are rolling out, so that every time we do a deployment, we can check if we are improving or not the fitness of our architecture. So one thing that you can do, for example, since this is within a stack, you can use introspection in the stack. This is an API call on AWS, and you can see all the software components or the services that are part of this deployment, how many S3 buckets I'm using, and so on. And then you can check functional, but also non-functional requirements. So I'm using encryption or not. You can also use another service that is called AWS Config that can monitor the configuration of your architecture. And you can define rules so that you know if you are compliant or not with those rules. And then, of course, you can check source code metrics before the rollout. You can check the performance after the rollout and use all this information to compute the fitness of your new version of the application. So, for example, those are a few checks that you can introduce easily in a post-traffic function. You can check that the encryption at rest is enabled on all S3 buckets or in DynamoDB tables. You can check that you don't have public access to your S3 buckets. You can define that only HTTPS is allowed protocol to access your S3 buckets, and so on. And if we look at rules, those are pre-managed by us. You can just enable them. And you can, for example, check that you enable logging and versioning of your S3 buckets, so that every change that you do as an history, you can go back and find the previous version of your data. You can also check that Lambda function have or don't have public access, because maybe you don't want to have public access only through the API gateway, and so on. So the idea is this pre and post traffic function that you execute before and after any deployment can analyze your architecture, can publish the result of the fitness function as a custom metric on CloudWatch, and then update your own product dashboard, so that the graph that we saw before becomes really part of the product dashboard following your software project, together with all the other metrics that you have, so the latency, the concurrent users, your top business metrics. As I said before, maybe if you're in an e-commerce, you want to know how many catalog search you have per minute, how many sales per minute you have, so that you can check that everything is going as expected for that time and day. So when you have this complete dashboard, then you can really know if the speed that serverless can give you is going in the right direction or not. And you can agree this with the business. I think that's very important. So let's see a quick demo of what I said. I have a reference implementation that is on my GitHub account. And so this is the URL, but Danilo is my GitHub account, so you should be able to find it very quickly. And I already deployed this before. So if we go on the AWS console, I have here, this is the CloudFormation stacks, so the implementation of those templates. I have a few. And the first one here, safe deployment, is this implementation. And those are the events here. If we go on the Lambda console, we recently added applications here as a first citizen. So if you click here on application, you can see all the CloudFormation stacks that has at least a Lambda function inside. You can select safe deployments. And here you can see the template and all the resources that have been created. So for example, you can go here and you can look at the template. So in this case, I'm creating a few random resources, like an S3 bucket with encryption enabled. So this part here is enabling the encryption at rest for the S3 bucket. This part here is a DynamoDB table. And then I have a few functions. So for the function, I define different deployment strategies. So this is my first function here. And for my first function, I want to have a deployment that is linear 10% every 1 minute. That means that every 1 minute, I release this to 10% more of my users. And in 10 minutes, it will be rolled out to all users. And I also add a hook. In this case, it's a pre-traffic hook. So before I roll out this new version to users, I want to do some check, and then I should give back a feedback to the deployment if this should go on or not, and I can publish my fitness result in the meantime. This is a second function. This second function is just using a similar configuration, but this is a canary 10% 5 minutes deployment. That means that I test this function on 10% of the invocations. And then if this works, so no alarms and the pre-traffic hook is OK, after 5 minutes, I roll out to all my users. Just to do this deployment, you just need to add these few lines in the SAM template. And then there's the pre-traffic hook itself that is receiving as input parameter in the environment the name of the stack and the ID of the CloudFormation stack, so that it can do introspection. It can ask to AWS, what is in my stack? Can I check the resources? So here, if I go, for example, on the resources, so let's close the template here. Let's go on the pre-traffic hook. This is the code of the pre-traffic hook. So I create a few services. I'm using JavaScript. It was probably almost the theme of the day. And what I'm doing, we can look at the bottom in the main function. I set my deployment status to succeed as stand. And then if something is wrong, I can change it. Then I run some tests. And these tests are run from this function here. And it's doing what I was saying before. So it's getting a list of all the resources in the stack. So I have S3 buckets, DynamoDB tables. Possibly I can have any kind of resource. I have Lambda function. Then, depending on the kind of resource here, I can run my own specific test. I can check if the database encryption or if the backup has been enabled on a DynamoDB table. I can check if a function is working or not. I can do one invocation to test that actually the function is working. I have this check here to avoid recursive invocation. This is very important because if the function is the same function itself, you would invoke yourself and create an endless loop. So be careful with that. And all those tests are actually put into a list. Here is an array of JavaScript promises. And then here I resolve all the promises together because those are probably 20, 30 invocations that can happen at once, so that everything is much faster. And then the list is returned here. And then I use an array reduce to sum up all the fitness. So I'm not using weights, but possibly you can introduce weights. I publish the fitness here. Then I report the execution status back to code deploy, because it's the tool that we use to say, okay, actually this should be a succeed or a failure. And then I publish the metric. So let's do a quick test here. So let's go back on the command line. Let's open an editor. This is my source code. So the function is already published, but I can change here. So this is saying just hello Milan from, so this is my first function. So I'm just adding Milan in the return of my API, hello Milan. So I save both. Now if I go here, I can just do the package and deploy. Is these two command lines that I already have. The first line is using the AWS SAM CLI to package everything and upload it on S3. And the second command that is here is actually using this as a deployment. So if I go back into my CloudFormation console, I see that now my stack is as an update in progress. And if I go here, I can see that there are a list of events. So a new version of the function is being created. And if I go here and I call my function, this is just a quick call, I see that I still have version 1 running. If I go on CloudFormation, I see that now the two deployment started for my function. So I can open the first and the second deployment. And we're using Code Deploy. AWS Code Deploy is our deployment tool that previously was only deploying on virtual server or containers. Now it can deploy also Lambda function. And this is a deployment. It's a linear 10%. So I can see that the pre-deployment validation, this is the pre-traffic function that I was showing before, succeeded. So the deployment is starting. Now 10% of my users see this deployment. And this is in progress. It will take roughly 10 minutes to do the deployment. And I don't have a post-deployment validation, so this step will be automatically implemented. If I click here, I see that I have the second function deploying, and this is a canary 10% 5 minutes. So for 5 minutes, it will stick to 10% of the users, and then if there's no problem, it will roll to all the other users. Again, the pre-traffic function ran here and succeeded, so no problem. So if I try to call the function here, it's a little bit early, but if we are, okay, we got a version 2. And now if I reload, we go back to version 1. So you see that the deployment is going on. And this is first function, so it's a linear deployment. So now only 10% is going to version 2. And then we're increasing this to 20%, 30%. It takes 10 minutes. And the same on the other one. So in this way, you can really control. And if we go here, this is a CloudWatch dashboard. So it's one of the components of a possible dashboard. And if we load here, we see that we have just a single point, because this is a new architecture. This is the first update that I did. And it's giving a fitness of 57. As I said, the absolute value of the fitness function is not really important, but you can use this to compare with new releases and to the impact of a change to your architecture. Actually, if we go back 1 week, we probably have a few more dots because I did some tests to see that everything would work on stage. You never know. And And you can see that the fitness is always the same because I didn't change the code or nothing relevant. So this is really just to give you an idea of how you can implement those best practices. You can really keep track of how your changes are changing the fitness, so the value, the business value of your architecture, and you can add this dashboard to your product dashboard for the next rollout. Thank you.